Hello students, welcome. Previously, Form 2, Topic 2, Lesson 9, we were dealing with physical properties of alkaline earth metal. So today, Lesson 10, we are going to deal with chemical properties of alkaline earth metal. The first one, we are going to deal with reaction of alkaline earth metal with air. And the members of alkaline earth metal that we are going to take are two. One is magnesium and the other one is calcium metal. So we start by seeing, first of all, the observation that will be made when magnesium burns in air. And the first observation is we are saying magnesium burns in air with applying brilliant white flame, or burns in air with a white flame to form a white solid. Okay, reason, this is because magnesium reacts with air to form a mixture of magnesium oxide and also magnesium nitride. So the reaction is, the chemical reaction will be 2 of magnesium metal or solid reacting with 1 of oxygen gas, giving us 2 of magnesium oxide, which is solid. So the one for magnesium nitride, we are going to deal with 3 of magnesium solid reacting with 1 of nitrogen gas, giving us 1 of magnesium nitride. So next, calcium. The observation that we are going to make when calcium burns in air is that calcium burns in air with a faint orange-red flame to form a white solid. And the reason for this white solid is that we are saying this because calcium reacts, I'm going to say calcium reacts with air to form a mixture of calcium oxide and calcium nitride. And the reaction for that formation of the white solid is 2 of calcium solid reacting with 1 oxygen gas, giving us 2 of calcium oxide, which is solid. Here we are having 3 of calcium metal or calcium solid reacting with 1 of nitrogen gas, giving us 1 of calcium nitride, which is a solid also. Number 2, we are going to deal with reaction of alkaline earth metal with water. We are going to start with magnesium metal. When magnesium reacts with water, we get magnesium hydroxide and hydrogen gas. The general formula is when a metal reacts with water, we get metal hydroxide and hydrogen gas. So the chemical equation, balanced chemical equation will be 1 of magnesium metal will react with 2 of water, forming 1 of magnesium hydroxide and also 1 of hydrogen gas. So the observation made when magnesium is dropped into a beaker containing water. The first observation is magnesium metal sinks in water, and the reason for that observation is due to its high density. So magnesium is denser than water. That's why it's going to sink in water. Number 2, produces a hissing sound. So, or we can say a hissing sound is produced, and this is due to the production of hydrogen gas, and that one we have seen that in the equation. So number 3, a white suspension is formed, and this is because the magnesium hydroxide formed is slightly soluble in water. Lastly, we are going to see an alkaline solution is formed, and this is due to the formation of magnesium hydroxide solution. So we are having an alkaline solution, therefore it's going to give basic properties like turning red litmus paper blue. Okay, B, that's calcium metal. The general the reaction is calcium plus water, giving us calcium hydroxide and also hydrogen gas. So the chemical or balanced chemical equation is 1 of calcium solid reacting with 2 of water, which is liquid, giving us 1 of calcium hydroxide solution and also hydrogen gas. So observations made when calcium metal is dropped into a beaker containing water is the first one, calcium metal sinks in water, just like magnesium. And this due to this high density, or because calcium is denser than water. Number 2, a hissing sound is produced. Reason, this is due to the production of hydrogen gas, because hydrogen gas is produced alongside calcium hydroxide solution. So number 3, a white suspension is formed. This is because the calcium hydroxide formed is slightly soluble in water. Then lastly, an alkaline solution is formed, and that's due to the formation of calcium hydroxide solution, which is a basic solution. So number 3, we are going to deal with the reaction of alkaline earth metal with steam. We are going to start with magnesium. Remember, when a metal reacts with the steam, we get metal oxide and hydrogen gas as our products. So magnesium metal reacting with the steam, we get magnesium hydroxide and also hydrogen gas. So the chemical equation, balanced chemical equation will be one of magnesium metal reacting with one of water, which is, steam, which is water in the gaseous form, giving us magnesium oxide, which is solid, plus hydrogen gas, one of hydrogen gas. So this is the setup that we are going to use when we are dealing with the reaction of magnesium and steam. So here we have the boiling tube, which is heated, and we are having wet sand is heated. Here we have magnesium ribbon being heated, the delivery tube, and we have this tube, and we are going to collect the gas there. And this is water. We are collecting that gas of water. So observation made when magnesium metal reacts with steam. The first one is magnesium burns in steam with a white flame. Number two, a white solid is formed. Reason, this is due to the formation of magnesium oxide. Magnesium oxide is white in color. Then number three, a colorless gas is produced, and this is due to the production or the formation of hydrogen gas, which is collected of water. So we are told, note, the first note is that we are told wet sand, or during the exam, they can use cotton wool instead of wet sand. So wet sand is heated initially, or first. Wet sand is heated first to drive out the air that would otherwise react with magnesium. That's the first reason why wet sand is heated first or initially. And the other reason is in order to generate steam. So during the exam, you can be asked, give two reasons why wet sand is heated first before heating magnesium ribbon. So the first reason is to drive out the air that would otherwise react with magnesium. Number two, in order to generate steam. That's the second reason why wet sand is heated initially or first before heating magnesium ribbon. The second note is that the delivery tube is removed from the water before heating is stopped at the end of the experiment. Reason is in order to prevent sucking back as the apparatus cools, in order to avoid cracking of the flask or cracking of that boiling tube. So during the exam, you are told, give a reason why the delivery tube is removed from the water before heating is stopped at the end of the experiment. So the reason is in order to prevent sucking back as the apparatus cool. Number two, calcium. The reaction between calcium and steam is explosive and dangerous, hence should never be attempted. That will be the end of our lesson today.